Hello, class 12th physics, optics, important question for boards as well as competitive exams. A ray of light traveling in glass of refractive index 3 by 2 is incident on a horizontal glass air interface at critical angle theta c. It means sine theta c is equal to 1 by eta, which is 1 by 3 by 2, which is 2 by 3. So angle of incidence, actually sine of angle of incidence we know. Now what is happening, it is incident at that angle, and if it would be there, and if air medium would be there, then they would travel this way, grazing along the interface. But this time there is a denser medium. Other than air, there is water, and we have given refractive index of that also. So I'm just simply drawing it in this way, and this is angle of incidence, which is this. Actually they have written it theta c, and we have to find this angle of emergence, they have said, but it is actually an angle of refraction. So simply we can apply Snell's law, sine I upon sine r equal to, remember, refractive index of this medium with respect to this. So refractive index of this medium is 4 by 3 upon refractive index of this medium 2 by 3. So sine I, which is sine theta c, we know that. We can put the value and we can find sine r. You can do it yourself. Next, a ray of light makes normal incidence on diagonal face. Here it is 37 degree, this ray incident, it will go straight. Now this is 37, so this is 37, this is 90, so this is 53. And now see this, in order to trace its path, I know this could happen, but this is also possible and this is also possible. If this angle of incidence is less than critical angle, then it will come out. If this is equal to critical angle, this will go along grazing way. And if it is greater than critical angle, it will bounce back. So here sine IC equal to 1 upon eta, and eta is given 5 by 3, so 1 upon 5 by 3, that is 3 by 5. Oh, I should write it down there. 3 by 5. This is the value of IC. And actually most of the time it is given that value of 3 by 5 is for when IC is equal to 37 degree. So it means, and they have given this theta also 37 degree. It means critical angle is 37 degree. And this angle of incidence is greater than critical angle. So this will also be 53 degree. It will go this way. And in order to find angle of deviation, so it was the original direction, it is the final direction, at this interface AB, then this will be the angle of deviation. Remember, original path and deviated path. So this will be considered as angle of deviation. So 53, 106, and you can find it out of your own. Next, a ray of light incident at an angle I from denser to rarer medium. Reflected and refracted rays are perpendicular to each other. The angle of reflection and refraction are r and r dash, then critical angle. Okay. So here you are, it's going from denser to rarer medium. Remember, whenever there is refraction, there is some amount of reflection also. This angle is r dash, this angle is r, this angle is I. So remember, this angle of incidence is just the angle of incidence. It has nothing to do with that critical angle. So how will we introduce that critical angle part? So we will apply Snell's law, sine I upon sine r dash. Let me see, r dash is refraction. Yes. So r dash is equal to refractive index. I use eta. Actually, we don't require that. I will, instead of using this, I will use this, sine IC. This is not this critical angle, this is critical angle. So this is how it is related to refractive index. And now we have to set a relation between these only. There is one more thing, that this angle is 90 degree. This entire angle, r dash plus 90 plus r is equal to 180. So r dash plus r is also 90. R dash plus r is also 90 degree. It means r dash is equal to 90 minus r. And then what? And what is r? This r is equal to I. So that is 90 minus I. And see, if we put it here, then it will be sine I upon sine 90 minus I, and that is equal to this sine, 1 upon sine IC. So further, you can make sine IC as a subject, and you can rearrange the formula, and you can find what is IC. That will be sine inverse and something something. Now this one, a point source of light kept at a depth h in water, refractive index 4/3. Okay, there is water. It is at the depth h, and radius of circle. We have to find radius of circle. Now, what is this? Actually, I have covered such type of question earlier also. So, see, actually, if the ray is coming out from here, will go straight away. If it is going this way, then it will move like this, but not always, because at critical angle, it will graze out. And at an angle greater than that, it will reflect back. So, the maximum angle that from which light can come out must be this. This is IC, and simple geometry, this is also IC. Forget about this. At critical angle, if it incidents, then it will not go out, but for smaller angle, it will go out. And see, this is. But if in 3 dimension, this is not a 2D figure. In 3 dimension, it will look like this. Something like this. This is that angle, IC. So, it will form a circle here. There's a cone of light, and we will see a circle here. So, we have to find radius of this circle. Means this is that radius, this is that h, and here it is. So, we can directly apply perpendicular upon base. So, that is tan. So, tan IC is equal to that R upon H. Now, what is this tan IC? Actually, we can find sine IC. How are we going to do that? So, sine IC is equal to 1 upon eta, and that is 4/3. So, it will be 3/4. Simple mathematics. And from here, we can find tan. Can we, by drawing a triangle and all that, of perpendicular 3, hypotenuse 4. So, this side will be √7, and that's it. Tan IC, plug this value here, and you can find radius. So, a white light incident on glass air interface. If green is total internally reflected, then emerging ray in air contain. Okay, so we know that in a medium, refractive index is inversely proportional to lambda wavelength in that medium. And again, we know that wavelength of red is greater than all other colors, and violet is the least. So next thing, refractive index is inversely proportional to critical angle. Not technically, but I can say that refractive index is inversely proportional to critical angle. So from here and here, we can conclude that critical angle for red is greater than critical angle for violet. And it means that if green is total internally reflected, it means angle of incidence is equal to critical angle for green. That is simply this I, which is for every other colors. So here, angle of incidence is less than critical angle for red, so it will emerge out, and angle of incidence is greater than critical angle for not green, violet. So it will total internally reflect back. So all the colors less than green, in fact green and less than green, will graze along or reflected back, and greater than that will emerge out. So greater wavelength than green is red, orange, yellow. So this one. So now make your choice.